Okay, guys, we're going to learn about something called rational numbers. Okay? Now, you've been working with these rational numbers for many years now. You just didn't know that's what they were called. Okay? So, any number that you can write as a fraction, so they call that AB form. And all that means is you can write it as a fraction. It isn't a funky number like pi that goes on and on forever, or a repeating decimal like 0.33333333. Okay, those cannot be written as fractions because their repeating decimals mean they go on and on forever, or pi is a irrational number and it doesn't repeat, but it just is a number that goes on forever. So those are not rational numbers and they can't be written as a fraction. We can't take those and turn them into a fraction. Okay? So any number that we can turn into a fraction in some way is a rational number. So for example, if I have 0.5, I can rewrite that as 5 over 10, right? Because my 5 is in my tenths place, which will reduce to 1/2. Okay? If I have 3.5, I can rewrite that as 3.5. And then I can turn that into an improper fraction of 7 over 2. Okay? So if I can rewrite it into AB form, it is a rational number. That can be positive. It can be negative. Okay? So any number that can be written as a fraction without a 0 in the numerator or denominator is a rational number. Okay? You just probably didn't know that's what it was called. We also will be comparing rational numbers. So if you look over here on this side, that's what we're doing with this anchor chart, is we're comparing them. Now, in order to compare rational numbers, you'll have to find a common denominator. So if we want to compare 1/2 and 3/5, we need to have a common denominator. So you already know how to do that using the birthday cake method or listing the multiples method. And 10 was found to be the common denominator then. We renamed our 1/2 to 5/10. We renamed 3/5 to 6/10. Then we can compare those with an inequality symbol, and we know that 5/10 is less than 6/10. So in order to compare rational numbers, we need to either convert them to fractions and then to common denominators, or you would have to convert them both to decimals if they had decimals, and then compare. Okay? Okay, let's talk a little bit about classifying rational numbers here, okay? So, if we classify rational numbers, we can do that very easily with this Venn diagram. So you're used to a Venn diagram kind of looking like this, where you're comparing and contrasting. That's not what we're talking about here with this Venn diagram. So when we look at this Venn diagram, what it is saying is that whole numbers are a smaller set of numbers, and they're all in this little circle. Okay, so these are numbers like 0, 2, 1, 10, 300, 16, nice, positive whole numbers. Okay, and if you're a whole number, if a number is a whole number, it is also then going to be an integer. It's also going to be rational. So whole numbers go in all categories, belong to all categories, okay? So whole number is a whole number, it's an integer, it's also rational, okay? Now, the next category, so we're kind of starting from the inside and working our way out. If a number is an integer, so that could be numbers like -1, -3. Now, another integer is 7, or like 15. Well, those are also whole numbers, right? But -3 is not a whole number, and -1 is not a whole number. They're just integers and rational because they're negative. So they can't come in, they can only go out. Okay? So, integers, if you're negative, you're only an integer or a rational number. So if you're an integer only, that means you're negative. If you're a negative integer, then you're an integer and you're rational. Okay? I'm going to put a little negative sign there. So if you're a negative integer, then you're integer and you're rational. Okay? So then, if you're rational only, it's because you're a decimal or a fraction. That's how that works. In order to only be a rational number, you are a decimal or a fraction. So integers do not have any decimals or fractions with them. Whole numbers do not have any decimals or fractions with them. So integers will be negative or positive. That's okay. If they're positive, then they're also whole numbers. If they're only negative, then they're an integer or rational. Okay? We're going to do some more practice with that. I know it sounds a little bit confusing, but if you look at this anchor chart, think of you can work from the inside out, but you can't come from the outside in. Okay? Okay, this is a really good chart that shows kind of what I was just explaining on the previous slide. So, there are example numbers here. So we have 75, we have -3, and then we have a decimal 35/100 and 3/4. So just to get this in your head of the right categories, 75 belongs in the set of whole numbers, integers, and rational numbers. So 75 is a whole number. That means it's also an integer. It's also a rational number. So you can work from the inside out, whole numbers to integers to rational numbers, but you can't work from the outside in. -3 belongs in integers, right? Integers and rational numbers. 3/4 is only rational, and then 35/100 is only rational. Okay? So you can't come from the outside in, but you can work from the inside out. So whole numbers, all whole numbers will also be integers, and they will also be rational. Negative integers will only be integers and rational. And then any decimals and fractions will only be rational. Okay? Okay. I hope that helps with classifying your numbers. I'm going to put 2 more notes at the end of this video that you can kind of glance at that might help you with identifying rational and integers and whole numbers also. Okay, so these are just 2 more notes that are showing you examples. So the one on the left here is saying rational numbers can be written as ratios or fractions. Integers are positive and negative. Every whole number is an integer, but not every integer is a whole number. They're also rational real numbers. And then it's showing you like the same kind of chart where here you see your natural numbers, whole numbers, integers, rational numbers. So this chart's a little more in depth than what we kind of need in 6th grade, but it does give us a good visual. And then it's explaining at the bottom, natural numbers are rational numbers. They're also whole numbers, integers, and counting numbers. Irrational numbers do not repeat or terminate. If you can't write it as a ratio or as a fraction, then it is irrational. So that goes back to pi, like I explained earlier, and like those repeating decimals that we talked about. And then over here on the right-hand side, it gives you another visual of like the Venn diagram with your whole numbers. Then we have our negative integers and our decimals and fractions. So whole numbers to integers to rational numbers. And then we have some more examples of how to classify numbers at the bottom. Okay? So hopefully that's helpful. You'll get the hang of it with some practice in identifying them. Okay, thanks guys.